I got a request for a problem on an old final, the Winter 16 final. And the written response, number 4. In this problem, you're working on an enzyme called phenylalanine ammonia lyase. We'll call it PAL for short. And you assayed it in the absence of an inhibitor, so no inhibitor, with a particular inhibitor, so with inhibitor A, and you also assayed it with inhibitor B, and you plotted out all of your information on a Lineweaver-Burke graph. And the first question you're asked is, what is the Km of the enzyme in the absence of inhibitor? So you would go over to the line that says no inhibitor. I'm going to highlight it here. And if you recall, in a Lineweaver-Burke plot, the x-intercept is -1 over Km. So let's read that number off of the graph. The x-intercept for that line is -0.4. So -0.4 equals -1 over Km. Cross multiply to get -0.4 Km equals -1. Km equals -1 over 0.4, -0.4, and that is 2.5. I'm adding my units here now, millimolar. And that is the Km for PAL, the enzyme that we're working on. So in part B, we're asked which represents the reaction mechanism for inhibitor B. So inhibitor B is this line over here. And so we look and see that both the y-intercept and the x-intercept have changed in the presence of this inhibitor. So Vmax and Km have changed. And you're told in the beginning of the problem, your inhibitor may be competitive, it may be non-competitive, or it may be uncompetitive. The only one of these three where you have both a Vmax and a Km getting changed is when you have an uncompetitive inhibitor. So that's something that you would have to remember, that when you have an uncompetitive inhibitor, that means the inhibitor comes in and can bind the ES complex. Can't bind the enzyme, can only bind the ES complex. And since that's an uncompetitive inhibitor, since you know from the graph that this is an uncompetitive inhibitor, then you would know that this is the reaction mechanism. And just to review, let's take a quick moment. With a competitive inhibitor, Vmax doesn't change, but Km goes up. For a non-competitive inhibitor, Km doesn't change, Km doesn't change, but Vmax goes down. And for an uncompetitive inhibitor, Vmax goes down and Km goes up. Oops. In the third part of the problem, you're asked to calculate the Ki for inhibitor A. And you must show your work and your units for full credit. So let's look at the inhibitor A line. We're going to be reading this graph to get some numbers. So earlier we talked about the Km for the enzyme by itself, and that's what I highlighted there. And we calculated that earlier, but I'll do that real quick again. And let's just fix that real quick. -1 over Km is -0.4, which when you do the algebra, your Km turns out to be 2.5 millimolar. Now let's take a look at the Km for inhibitor A. So I'm shading this here. So for the inhibitor, the x-intercept is -1 over Km apparent, which is the Km apparent in the presence of inhibitor. Read that point off the graph, the x-intercept, that's -0.1. You cross multiply and do the algebra, you get a Km apparent of 10 millimolar. So for this type of inhibition, you're looking at that inhibitor and you're seeing that compared to the no inhibitor situation, your Km has changed. The Km apparent is Km times alpha. So in the presence of this inhibitor, your Km has increased. And you would have to remember, and you actually see that here. That's actually pretty ugly. You see that here, and you see that here. And so, you know, you could recall that in this case, Km apparent equals Km times alpha. So your Km apparent is 10 millimolar. Your original Km is 2.5 millimolar. And you can solve for alpha, which is going to be 4. This is really useful because alpha equals 1 plus inhibitor concentration over Ki. So once you've calculated your alpha, you can use that equation to solve for Ki. So plug in 4 for your alpha, 1 here. The concentration of an inhibitor you're given in the intro to the problem as 100 micromolar. You need to convert that to millimolar if you want to report the answer in millimolar. And be consistent with the Km, but actually I see that on the key, but you don't necessarily have to do that. So let's not do that. We got 100 micromolar over Ki. And now we subtract 1 from 4, and we got 3 equals 100 micromolar over Ki. Cross multiply, 3 Ki equals 100 micromolar. So your Ki equals 100 divided by 3, which is 33.3 micromolar. In the key, there's a conversion to millimolar, so then your answer would be 3 decimal places different. It's 0.0333. But as long as your units match, makes sense with the math that you did, then you got the question right. If you have further questions, please let me know on Piazza or by posting below.